vision, to perform R group analysis, go under File and import some molecules from a file of interest. In this particular case, I am importing a subset of molecules from the Kimball database. These are 21 molecules that have an associated activity with them. To perform the R group analysis, I'll need some scaffolds. So we come to the scaffold tree panel located in the upper left underneath the menus. Right-click in that panel, and you can either draw in a scaffold that represents your molecules, or you can ask SAR-Vision to identify scaffolds that are relevant to this data set. Accept the default options and press OK. And the program will find a scaffold or scaffolds that represent your data set. By double-clicking on this scaffold, you can reorient the molecules in the data set and map the common scaffold core onto the molecules. To see an R group table, go to Insert R group table, and this will display an R group table with the scaffold at the top. Any position on the scaffold where the molecules are varying will be labeled with a capital R with a number following it, R1 through R6. These positions correlate with columns in your data set, R1 through R6, that contain the varying chemical motifs. In this case, we have too many R groups for analysis, so let's right-click on the scaffold and edit that scaffold. And we can remove part of the molecule. We can also modify it any way we feel is important or change its orientation. In this case, we'll just remove the ethyl group so that the nitrogen at the end of the molecule is bare, and we will hit the Accept button. Now when we double-click on that scaffold again and rebuild the R group table, we only have 4 R groups. We consolidated the 3 R groups associated with that nitrogen into a single R group, R1. So now we have a cleaner R group table to analyze than we had in the previous case. Now that we have the table, we can double-click on columns to sort them. In this case, I sorted the activity such that the most active molecules are located at the top and the least active at the bottom. I can right-click on the header and I can perform a heat map. We'll do a 2-level heat map where we start with 0 micromolar and go through 3 micromolar, and we will color code that going from green to yellow, and then we will go from yellow at 3 micromolar to red, and we will max it out at 6 micromolar. So in this case, the good molecules, the most potent molecules, will be green, and the least active, we'll color those red, will be red. Anything at 6 micromolar or greater will be red. And when I hit OK, we have a column that is heat mapped from green to red, most active to least active. More options are located under the R group table tab. We can right-click on that and we can change the column height of our headers. So columns that have long names, we can make them wrap cleanly into a nice column. We can go under columns and hide columns that are not of interest to us. We can sort multiple columns at a time, or we can export to different programs. For this example, we'll export quickly to Microsoft Word. We have a pop-up to select columns. We will show the R groups and the 3 Kimball columns, and I'll hit OK, and this will export to Word. So in the span of a few minutes, we have loaded in a set of molecules of interest, identified a core, created an R group table, and we've exported into report format. The Word table mirrors almost exactly the R group table that you had in your program, except that you can now print this out or submit it in a quarterly report or a patent. For more advanced R group analysis, we can add a second table called the comparative substituent analysis. So under Insert, comparative substituent analysis, we add a third view to our program. And double-clicking on our scaffold will cause that table to build. What this table shows are pairs of molecules that vary at only a single position between them. All parts of the molecules are identical except for one position. And these are centered on a common scaffold. So these are scaffold-centered molecular pairs. So on each row is the first molecule and the second molecule, color-coded by scaffold and by the varying position, a column showing the R groups and how they're changing, and then properties in the following fields. So we can click on the activity that we're interested in. Because the column name is very long, we can turn off the column name by clicking the Show Column Names so that we can see activities in our table. So in this particular case, we've gone from 2.2 micromolar to 3.6 micromolar, a change of minus 1.4 micromolar, or a ratio of 0.61. We can analyze our group substitutions in the absence of any other confounding substitutions on the molecule. So it's only a single change between two molecules. If we want to add some visual heat mapping to us, we can click on that column in the control on the right click on that, and we can add a heat map. This heat map control is identical to the previous one we did in the R group table, and we can press OK for a simple heat map from min to max, and we have a color perspective. Green means they're mostly the same, and then we have some that get worse and then some that get better, and we can analyze the table very quickly for individual single point changes on the molecule.